Imagine dropping a piece of metal into water. You'd expect a splash, a quiet sink to the bottom. But what if instead it erupted into a ball of fire, zipping across the surface like a tiny, furious rocket before exploding? This isn't science fiction. For a special family of metals, it's a violent reality. But the reason why is far stranger than you might think. The culprits belong to a group on the periodic table called the alkali metals. In their pure form, they look surprisingly gentle, soft enough to be cut with a knife. But this softness hides an extreme chemical impatience. They're so eager to react that they have to be stored under mineral oil just to keep them from attacking the moisture in the air. When one of these metals hits water, the reaction is instant. It rips apart water molecules to create hydrogen gas. This reaction is intensely exothermic, meaning it releases a huge amount of heat. That heat is more than enough to ignite the flammable hydrogen gas, creating the flames and pops you see in chemistry class videos. And the drama escalates as you move down the family line. Lithium, the lightest, fizzes gently. Sodium melts into a silvery ball and skates across the water, often bursting into an orange flame. Potassium is faster, more violent, instantly igniting with a beautiful, eerie lilac flame. Rubidium and cesium are the heavyweights. They're so reactive, so explosive on contact, they often shatter the glass containers they're dropped into. For years, this escalating fiery reaction was the whole story. But it wasn't. Scientists using high-speed cameras noticed something else, something that happens in the first milliseconds of contact, even before the hydrogen has a chance to ignite. They discovered the real explosion isn't just the gas, it's the metal itself. As the metal touches water, it sheds electrons at an impossible speed. This leaves the surface of the metal intensely positively charged. And what do like charges do? They repel. This powerful electrostatic repulsion is so strong, it causes the molten metal to literally tear itself apart, erupting into a series of microscopic spikes that shoot into the water. This phenomenon, called a Coulombic explosion, massively increases the surface area, creating a runaway feedback loop that accelerates the reaction to its violent conclusion. The metal doesn't just burn, it disintegrates from its own internal charge. This isn't just a lab curiosity. In 1947, barrels of surplus sodium were dumped into Lake Lenoir in Washington, turning the lake into a minefield of explosions. And this same untamed reactivity is what we harness, very carefully, in the lithium-ion batteries that power our phones and cars. The very thing that makes it dangerous is what makes it useful. So when you see a metal explode in water, you're not just watching a simple chemical reaction. You're witnessing a story of atomic impatience, a fundamental force of repulsion made visible. It's a powerful reminder that even in the most common elements, there are hidden violent forces, a breathtaking dance of electrons waiting for the right moment to be unleashed.